What's going on, guys? Welcome back to the N3K channel. I am Mike, your host, and I will be taking you through another tiny Unity tutorial today. So this one's going to be a little bit simple. We're going to go inside of that, we're going to create our project, and we're going to create a movement script, something quite simple, so we get the feel on how to work with this new engine, and also we get a little bit of the feel on how to code with TypeScript and also ECS. Now, if you like this content and you're interested in more Tiny Unity tutorial, please let me know by hitting the like button on the video, and also make sure you subscribe, because in 2 days or 3 days from now, I will have a video on how to export this over to Facebook Messenger. So you'll be able to play your game directly inside of Facebook Messenger, whether that is on the browser, so on your PC, your Mac, whatever, or on the phone itself. So stay tuned for that, make sure you subscribe, and let's jump in today's video content. So back here on my screen share, as you guys remember, if you watched the last video, we need to have a Unity version that has this new preview package of Unity Tiny. Now this starts at 2018.3, I believe. If you don't have it, head over to Unity Hub and download it directly from beta releases. From that point on, I will create a new project. This one can be the Tiny example. And what we'll do here is we'll just make sure this is on 2D. I don't need anything very fancy. Don't need analytics either. Just make sure you boot your project with a version of Unity that has the preview package. As I mentioned, anything above 2018.3 should do the trick. Once the engine is booted, we're going to do the exact same thing we've done in the last episode and turn our engine to the new UI by getting the Tiny Unity package. So let's head over to the window, Package Manager, and go under Advanced, Show All the Preview Package, and let's make sure we grab the Tiny mode over here. Let's install that. It's going to take a little bit of time. Alright, so we're back. We have the Tiny mode package installed. Now it's time to create our project. Technically our project is already created, but there's a different notion of project in Tiny Unity. You need something called a UT project file, I believe. To create that one, let's over at the top here and click on File, New Project. Let's call this one, well, I'll call this one Tiny Example. This will save over in your folder as a new folder. It will create a hierarchy of folders in there: component, entities, scripts, and then the Tiny example. That's your UT project file. So as we created that project, it automatically swapped us over to the new mode of editing. But in case it didn't, in case you're booting this up and you have the standard game object editing fashion, you can head over to Tiny and then open the project by clicking on the UT project file. Okay, now you realize that there's a couple of things they've created for us. This first thing is a new entity group, and they've created a component folder for us to use. They created the project itself and a script folder. So if you've never really messed around with ECS just yet, it's quite a different way to code. I'm not going to lie, if you're used to object-oriented programming, it's going to be a big shift. But let's go together and create two simple systems. One that will be reading our player's input, and one that will be moving him around. We need a couple of things for this to happen. First, we're going to need an entity, a player entity, that will hold different type of component. So now I will get started and I will declare our player entity group. Right now it is an entity group, but the player itself could just be a single entity on its own. We have the option to create him just as a single entity, but in the future you could want more things than that in a player. I also want to call it a prefab. So this could be like a player prefab, and it contains multiple things in that. It could contain a camera if you're attached directly to him. It could contain some effect around him that keeps on moving. It could be really anything. So we'll define it as a group. The main reason is because I want to show you how to instantiate a group. That was not so evident in the example. And yeah, let's go from there. So right now we have a new entity group. That's the one they made us by default. We're going to call it player. Now, note that when you only have one entity in your game, you need to have at least one entity, because you need a startup entity, something that is being launched when the game starts. So if we start this, we know the player is going to be there. We know that the entity player is going to be there. However, if we create a new one, so if I go over here, create Tiny, new entity group, and I call this Bootstrap, well, now Bootstrap is not going to be inside of our build, simply because it's not set as a startup entity. So it's not there from the beginning, and we never load it at runtime. We never instantiate this one at runtime. We will leave the Bootstrap entity right there for now. We'll come back to it in the future, because that's where we want to start our game. Right now, I just want to start defining a couple of niche things for the player himself. So the player himself doesn't really have to be a camera. In fact, I don't think there's going to be a camera to the player. I think the scene or the bootstrap is going to be the one that contains the camera. The player, if we right click on him, I'd like him to have something such as a sprite. So I'd like to be able to render a sprite. Now I don't have anything quite cool in here, so I'll just go grab an image somewhere. Alright, so I've imported a new sprite under my texture folder. So I've created a texture folder and then I imported the new sprite. You can then assign it directly under the component. So I have my Borking Shiba over here. So this player could have a lot more of predefined component. This one even, you can have a particle system going on there, and there's a component for that in Tiny Unity, which is something I didn't actually know, so I'm quite happy about this. But yeah, so here is actually where we are going to start creating our own component. As we said, we'd like to have one that keeps track of the input of the player. Why? Well, because there's going to be another system somewhere that reads those input and move him around. So to go ahead and do this, we're going to have to create, if we head over here under our project, I just realized I made my texture outside of my project, let me put that in. Under component, I will create a new tiny, this one will be a new component. I will call this player input. So every object that will hold a player input component will know about my player input. That's my goal, that's my thinking going into this. Now, what kind of information do I want to keep in here? Well, if you head over to the player input component on the inspector, you'll find that you have to add new field again, but this one is not the same field. Those are actually a little bit lower level. So you have things like int 8, which would be a byte, and you see all the base that you're used to. There's also, if you head over to another library, so Unity Tiny Mat, you'll find your vectors over here. So we'll take a vector because we're going to be only taking the inputs from horizontal axis and also vertical axis, and that's what I'll be using this for. I will call this axis, and the data that's going to be put beneath that at runtime is actually going to be, okay, am I pressing left, am I pressing right, up or down? So what exactly is my vector I get out of those two axes together? Now going back on our player, you'll find that we have two components. We have the transform, we have the sprite renderer, but we want to have our player input as well. I believe you can just look it up like this. You'll find it right away. It has what we define under the player input, so it has the axis vector 2. I think you can also drag and drop him. Yep. And here you go. Now your player entity has an additional component. At this point, what we could be doing next is start assigning everybody in our scene, everybody in our world that has the player input. We could be assigning our input to it, because we got to do that at one point, we can't just leave it on 0, 0. Now to do that, we're going to be using a system. So this is when the system come handy. Under script, I will be creating a new tiny TypeScript system. I'll call that player input system. Now remember, we have to deal with TypeScript for a little while, at least until they port the C# over to this Tiny Unity version, but until then, you'll have to deal with TypeScript. It's not really that complicated. If you're swapping over from C#, you're going to have a little bit of hiccup, but you'll get there in time. With a little bit of Googling, you'll be able to get through this without any issue. Now this will open up in Visual Studio, but if you'd like to have better formatting, you can actually open this up in Visual Studio Code. For my purpose though, I actually kept Visual Studio because I can zoom in quickly, so when it gets late at night, I can actually see things. Okay. So when you have a system, it runs automatically. So this thing, if we just save this, this is going to be put directly inside of your game, and it's going to run automatically if the condition we're about to define is met. So we just have to create it and it's going to be there basically. However, in a onUpdate loop, we have to look for a certain type of entity, actually a certain type of component that are assigned to certain entities. So in this update loop, what we have to do here is we have to go grab every single component that we want to have an effect on. Right here, we're only looking at one simple component. We're looking at the player input component. This is the player input system. And our player input system will have an effect on player input component. I didn't really want this to turn into an ECS tutorial, but I want you to get like a feel for it. So here's the code we write. This.world, this, if you did a little bit of C# with entity manager, this would be your entity manager. And then you do a for each, and I have my other screen here to guide me with this. At this point, this is where you do your filter. So this is where you define exactly what component you want to affect. In our case, player input is the one we want to affect. Now, if you realize, we have a namespace up here called game, and this is where everything that we personally define is going to be stored. So if I type in game, you'll find I have the player input and also the player input system instead of that namespace. We want to have an effect on player input. So this is what we put in here. That's the only thing. So now that's one way to do it, but don't worry, we'll have another example with the movement system in which you'll have more component and you might get a better feel on how this works. Just stay tuned to that. Okay, so once you define all the component that you want the system to affect, and please do note, so if you add another component, assuming we also want to affect the transform position. This one is defined under UT, so Unity Tiny, core 2D, and then say transform local position. If you want to do that, and you want to include two things in there, you gotta make sure that the component you actually want to affect, the entity you want to affect, say the player in this case, has these two. If he only has one of these, you won't be filtered through that. He won't run a unupdate loop on him because, say, he doesn't have a transform local position. Now we're lucky with the example I just gave. Right now, he does have a transform local position. The player entity has three things: player input, sprite render, and the transform. So that will work right now. However, that's not what I wanted to show you. I wanted to show you the fact that if the entity you're targeting with your system doesn't hold all the component you define here, well, that's not going to work. Okay, so on the second part here, you want to define variables for you to use the system in order. Right now we only have one, so we'll just put a variable name input. Now we're going to format it a little bit, so input's going to be on the second line. We're going to start a new function with this, and let's make sure we close our for each real quick, and it's going to look like that. So do we get any errors? No, after compiling, everything seems to be clear with that code. So let's go ahead and do a console.log. We're not doing debug.log, we're not part of Unity actually. When we hit play, we're in the browser, right? So we're not going to hit a debug.log here. We're going to do console.log and just say alive. Just something like that. I just want to see if we're actually going through this. Right, so let's save this. Now, what I'm going to do is to first show you, we're going to open this up with a player input component on our startup entity. So we know that this entity is inside of the game because it's the startup entity, right? Let's actually grab this over here. So nothing seems to be really happening. Let's over to console. Let's see, over to console. And we get false. What is that for? It might be because we don't have a camera. That's something I've noticed, but I'm not sure if that's the problem. If that's the problem, then you know why. So I'm going to go over to my my player entity. We're going to load this up, and we're going to add a new camera object under the player. Okay, and we're going to try this once more. Let's hope this one works. And here it is. So I have a meeting really soon. Crap. Okay, so we have our Shiba, our barking Shiba, in the screen. We're being spammed with alive, so we know that the onUpdate is being called. So this system is actually going through it. It's actually calling some code. Now what we're going to do is we're going to head over here, and in our engine actually, we're going to turn this off. We're going to make sure that, say, our player doesn't have that. Just giving you an example, guys. You know what's going to happen, right? So I removed the player input component. We're going to head back inside of our game. So that's in our browser, of course. It's been refreshed on its own. If you don't trust me, here's another refresh. You'll see that, well, the icon was not found. That's not a problem. But we're not getting that update loop. Why? Because our system cannot find anyone with the player input component on it. So if I head back to my player, I'm going to add this again. Player input, and now we're going to do it the other way around. So I'm going to go in here. I'm going to say on top of having a player input, I also want you to have a UT. We could do particle burst emission. I don't know if this one's is going to work, but we'll also have to hide it in here for it to compile. Okay. So now we're looking for two things. We're looking for the player input, but we're also looking for a burst emission. And once again, as I explained, you know what's going to happen. Nothing is happening. Why? Because our player itself, yes, it does have a player input. However, it doesn't have a burst emission. Therefore, this very specific entity is not being parsed. It's not being filtered to go inside of that loop. Okay, let's go ahead and remove this real quick and create our code logic real fast. I gotta take a break soon and go to a meeting, but I'll be back. So I'm gonna start by defining a new vector2. That's actually what I've been using for my left and right, so horizontal and vertical axis. Horizontal would be on X and vertical would be on Y, of course. Now for the input, we have access to this very specific piece of code, so the runtime library, and we have input. And then in here, part of core 2D, don't ask me why, but it's part of core 2D to have the key code. So the key code is inside of here, and then we can do something like axis.x is going to be equal to -1, or actually let's do plus equal to -1. And we'll just duplicate that a couple of times. So, oops, let's duplicate this. Oh, sorry about that, I forgot the get key. So the get key call, I totally forgot about that. Don't know why, but here we go. We're fixing this now. Okay. Now once more, it doesn't compile right away. Sometimes it takes a little while. As you can see, there's a delay. So make sure you're patient, and if you see that it's stuck and it should work, well, head over to the actual engine, and it's gonna recompile there again. Right. So what we just did right now is nothing because we forgot to assign it. But let's do that here. So we'll do input.axis. That's the vector 2D beneath our player input component is going to be equal to the new one we've defined. Right. Now, if we head over here inside of the game, we are going to see this value change. Actually, we're not going to see it. Why? Well, because we're not playing in the editor. We don't have any console.log. We don't have any access to see this while it's running because we're playing over in the browser. So what we could do instead is we could basically just ask the player to print that out, see if it works. So let's do, because this is on player, let's do something simple as this. So you're going to console.log the axis. And now by doing this, we should be able to see the player in the screen, just like before, and we get this spam on the right hand side. And if I'm holding D, you'll see it going to 1, A is -1, S is -1 in Y, and W is Y in 1. Okay, so I gotta go for a moment. I'll be back in the future with a movement system. Actually, you guys won't even notice, it's a video. Alright, so I have returned. Sorry about that. Where were we? We had inputs. We were reacting to our key press. Okay, we got that. Now what we have to do is a movement system. I want to move around this small doggo across the screen. So that's going to require a whole new script and a whole new system. Takes a bit of time sometimes. Okay, so player movement system. We will have some pre-generated code in which we'll just build upon. Now, there is something quite cool with the ordering of this. If you guys have a look in the player input system, every single frame or every single update loop, we reset the axis back to vector 0, 0. So 0, 0, 0 in X and 0 in Y. Which means that if we have like an execution that goes like this, we update the movement, then we update the input, we're never going to move for a simple reason that, well, if we update the movement using the input, those input have to be set before we update the movement. Therefore, what we can do is right above our class, we're going to say at ut execute after, and then we'll be using our game player input system. And just like this will ensure that this player movement system is being executed after player movement system, and there's no ordering problem with this. So let's go ahead and actually start defining what kind of entity or component we'll be looking at in this case. We said we want to be looking at something that has player input and also has a transform position, so local position. So we'll grab our entity manager, in this case it's this.world, and we'll do a for each, and we'll look for the component we're looking for. So what are the component? We need game player input, and we also need UT and the transform. This transform is actually held inside of core 2D, and we'll be looking at transform local position. All right, let's go ahead and make our second parameter our fields. So in this case, this will be input and this will be transform, or we can call it position because we're just grabbing the position. So the arrow function, and here we are in our update loop with apparently the proper entities, the proper component. We also have to wrap this up real quick, so let's go ahead and make sure we close our for each. And this is not where you close your for each. This is where you close your for each. Okay, TypeScript, nice. So what I will do now is I will take the input from a player and I'll apply it to its transform position. Now, the player input are actually a vector 2D and our local position is a vector 3. So what we'll do, we're going to declare, by the way, I put let here, it could be a var, but let actually stays within that scope, so it's a little bit better in our case. We are going to say let r is equal to our position.x, or position.position.x. So position is a transform local position. We could rename that to transform in this case, so it's a little bit less confusing. Okay, so transform.position.x, and then we'll do plus equal our input, which is the other component we fetch. So input axis x, and let's close this off. We'll come back to it in a moment. Now, let's do the same thing for y. And as you can see, we now have our two values, so x and y. To apply it after that, we have to make sure we reassign the transform component. So let's go ahead and do this. Transform dot position is equal to new vector 3, so we're going to create it on the fly, x, y, and 0 because we're not moving on the z-axis. So let's save this and have a look at what happens in the game. So back in my browser, as you can see, I can move, and I move very, very quickly. But it's moving, and we can move in diagonal, we can move left and right. Everything seems to be working. Now, at this point on, we pretty much realize what we have to do. We complete the goal of this video, but if you stay a little bit longer, I'll teach you about some neat little tricks that you'll need eventually if you do want to get involved in that. But your project here is moving. So what I'll do here, obviously this moves way too fast. Usually what we do in Classic is we multiply that by times the delta time. However, we don't have delta time here because everything is in different module at this point. Everything is like very, very small module base in Unity Tiny, or UT if you want. So we have to find where the delta time is. So for Unity Tiny, the delta time is actually hidden beneath something called the scheduler. So scheduler, this scheduler dot delta time, and it's a function, so you have to go get it like so. From what I've seen in the other example, people create their own time class and they reproduce that using this value. So this is where I found my delta time. So we've done it that way. Now our player is going to start moving a lot slower. It's going to be easier to keep track of him. But what I'd like to do now is I'd like to create some kind of game flow around that. We haven't created an entity just yet. We haven't used our bootstrap. So let's go ahead and do that. So my goal for the next few minutes is I will take my bootstrap. I want to start the game as bootstrap. I then want to press any button so I can start my game. And then when I press the button, I start my game. So we're creating some kind of game flow here. So let's go ahead and do that. Let's go on our entity folder, click on bootstrap, and make sure this one is the startup entity, which means from this point on, you press on play, you ain't getting nothing. The sole reason is, well, you have your bootstrap entity, but there's nothing beneath it, right? Okay. Actually, I pressed play on that, but I haven't give you the example. This is what happens. First, you have the display list system that throws an error, and we know that this one is because we don't have a camera. We actually experimented with that earlier. Okay, so let's actually make sure we have everything we need here. Quickly again, I will load up my player, and I'll remove the camera. The camera won't be part of the player. Then I'll make sure to save this, head to my bootstrap. You can have both loaded at the same time, there's no problem with that. As you seen in the first video, you can load them, you can unload them. Say I don't want to work on my player, unload entity group, and here it is, it's cleared. If you want to have it again, you can load it directly here in the menu. So under my bootstrap, here is what we'll be doing. First, let's make sure it is a startup. So right now it is. I am then going to create a camera beneath it, and that's going to be my main camera. I'm just going to leave it as is. Next up, I will create an empty object on this that I will call Game Manager. This will keep track of my game. This will keep track of the general flow of my game. To do this, we're going to need a component. So let's go ahead and keep our game state, our game values, like our general game values, let's keep them inside of a component that I will be calling game context. We could do, yeah, let's call it game context. And then I'm going to add my game context straight on the game manager. Now in the next part, I'd like to actually add some kind of state to my game. So I'll know if it's like in the startup state, if it's in the game state, where exactly the game is. I'd like to know that. So a couple of ways you could go about this. You could create a string and just reference that with a hard string. You could have a byte and let that byte tell you exactly where you are. In my case, I would do the byte usually, but let's do the string. Let's do the hard reference to string. I'll call this one state. Default value would be same menu. We're gonna start straight at the menu. Right. So having that done, we're gonna need one more thing. So that's the component. That's the game context component, and that component is on top of Game Manager. Now to make this run, to have this actually do something, we're going to need a system that acts as some kind of behavior object. So I'm gonna head down under the script, and I'll create a new tiny script system, and I'll create a game manager system. Okay, let's open this one up. Now, knowing that we're going to structure our game in such a way that there is only one game manager, we can go in here and create the same thing as before. Even though it's one, you have to put the for each anyway. So let's do that here and wrap it up properly. And we'll simply say we don't need anything else but game.gameContext. And I'll add that right here, so context. Okay, so we got that right here. Now inside of here, we're going to do a switch case in here. So we're going to switch depending on what is the state of the game. So let's go ahead and do switch on the context.state, which is of course our string. And then we'll check. Okay, so is my, are we in the menu right now? So if it's the menu, we'll leave it here, so break. We'll also do, are we in the game? And that's gonna be our two simple state for today. Right, so if we are in the menu, what I'd like to do is check. If we press on the key, if we press on spacebar, I'd like to be able to change, not change the scene, but load up the player. Like actually instantiate the player and have him moving around. So a couple of ways we could go about doing this. We could reference the runtime right away. So the UT runtime input get key down. So get key, say down, and then we do UT core 2D key code. And this one would be, say, spacebar. We could do that and actually here do our spawning logic. Or what we could do, if you want to be a little bit more cool, I guess it's not as efficient, but what we could do to be a little bit more cool and maybe have a better understanding of what's going on with the script and all the systems, we could actually go up here and say, hey, let's also let's grab say the game manager that has a context, but that also has the player input in it. And I believe game.player input is what we're looking for. Okay, so from that point on, we're going to have access to the horizontal axis and the vertical axis. So basically, player input.axis. And from here, we can say, okay, so if, let's go up here and add it. I forgot about that. If input.axis.x for say is bigger than 0, it means we press on D. Something like that. And then we can do our spawning logic. So that could be cool. I'm actually going to leave it like that. So we're going to be able to start the game using D. Now note that if we want to do like, oh, you spawn, not you spawn, but like you start the game when you press on spacebar, we would have to go back in our player input system and actually do a condition for that. In which, since we're here, let's go ahead and do it, right? We'll do get key down. if I can type, get key down, core 2D, key code, spacebar. And if that's the case, we are going to assign a new thing to this. So it's going to be, say, input dot maybe space is equal to true. Oh, and we're missing a T here. So this seems right. However, if you press on spacebar once, it's going to stay true forever, basically. It's going to maintain its state over time. So if we don't want that to happen, every time we do an update, let's go ahead and say input.space, which isn't defined just yet. This is going to be equal to false. So every time we reset the input, just like it should be. So having that done, we are now going to add a new player input, a new field in our actual component. Sorry about that. I'm getting a little bit tired here. So we'll do a boolean. I'm under player input. We'll call this one space, and default value is going to be false. Okay. Having that out of the way, we should now be able to get the inputs every time we press on spacebar, as well as horizontal and vertical axis. So this will now compile properly soon. As you can see right now, it's showing me some error down here, but it should actually be fine. You just make sure that you type the thing properly. Sometimes it's going to take quite a lot of time before it actually updates. So having that done, our player input are going to be updated. Just know that the player is also going to receive this information as well now, not just the game manager. Speaking of which, let's add player input to the game manager. So now, at this point, it means that the game manager himself, the entity game manager, will have two components. One that knows about the state of the game, it's only a string, and another one that will always have fresh input from the player. So if we play this right now, with the game manager that has the player input and the game context, this will run the game manager system because the conditions are met. So if you guys remember, do we have an object that has a game context and player input? Yes, that's a game manager. It's going to run. Under player input, it looks, does it have any entity that has the player input component? Yes, the game manager has player input, then it will run. Now, do we have any object that has player input and a local position? Doesn't seem like it in this case because the game manager doesn't have a transform. If you can see it, hey, at the top, doesn't have a transform. Therefore, 2 out of 3 system will run. Player movement will be discarded. It's not going to show up. It's just going to say it takes 0.0 millisecond to update because nothing's happening. And Unity is smart enough to know that. Okay, so if we're to play this, really nothing happens, right? We don't need to show you that nothing happens. You know nothing happens simply because we don't have any logic in here. So let's go back to our game manager system and say, well, if we press on spacebar, let's go ahead and change the state of this. So context.state. Oops. And let's go to a game state, right? So if we want to see this in work, we can do console.log and log the context.state every single frame. I'll just quickly make sure this works by pressing the play button. And of course, looking in the browser. Takes still a bit of time. We don't have all the tools we need at the moment, so we don't have, the debugger, we don't have the profiler. It's kind of hard. We have to deal with the browser, but I'm sure things will get better. So as you can see, we're in the menu scene on the right hand side. If I press on spacebar, we're now in the game scene. Isn't that wonderful? Well, it's quite simple, but yeah, it's wonderful. Amazing, actually. Okay, next step, we're going to spawn our player. So we're going to jump back inside of the game manager system here, and we're gonna spawn our player entity group. Remember, this is not just an entity, it's actually entity group. If it was an entity on its own, we could do the following code. So this dot world, which pretty much is the equivalent of the entity manager in a C#. Then create entity. Also have a look at the world here. There's a couple of things you'll be able to do in the future. If you go a little bit deeper in this, you'll find out that you'll be able to add a component. So that's what it means. You add a component, you do a type of, say you want to add a component to a certain entity, so the player in this case. That's not a reference, but you know what I'm talking about. You could do something of the sort. If you have a proper entity. In this case, we don't. So to spawn a player, well, actually, to spawn an entity group, it's a little bit different. You don't just do this.well create entity. You actually go through entities.game, which is you, and then what you want to spawn there. So in my case, I want to spawn the player. This is a way to do it with hard reference. Before that, from the example I saw, it was a little bit more complicated. I will actually show you in a moment, but here. So you do a .load, and they ask you which world. Well, this world. And just like this, we'll have loaded our player. It's gonna straight up show on the screen, and we'll have access to controls right away because the player, that entity group called player, has the player input component and a transform. So we'll be able to move it around just like that. I think the other way to do it was like this. So you have to get the entity group from Unity Tiny, and then you do a instantiate, yeah, just like this. Which world? Well, this world, and then you have to pass in a string, just like so. So game player in our case. But I'd rather do it this way because it's, you know, it's hard reference. You don't have to deal with strings. So, having that said, let's test out our awesome game. I'm being sarcastic, if you haven't noticed. Okay, it should reload on its own, so we'll see that happen in a second. There it is. We're in the menu. I'm gonna press on spacebar. The dog happy is, and here we are. As you can see on the right hand side, we're getting 2 debugs. Why do we get 2 debugs here? Because the game manager, which still exists, has a player input component on it, and the dog, the player, has a player input component on it, which means that both of them, they run one after the other in the update loop. And we can make sure we don't have that, of course, if we just remove the console.log, but it gives us a good idea of what's going on during a frame. So this is being ran twice. So once for the game manager and also once for the dog, the player object. Alright, that's actually where I will conclude the video today. Thank you so much for watching. Make sure you subscribe because next time we're going to be going straight on Facebook Messenger and we're going to be building our game directly on there. We'll be able to play directly inside of Facebook Messenger. So subscribe. Look out for that video. Join Discord. Join the clan. Have fun. Chill with people. Become a subscriber. I said that already, right? Well, you know the drill. Just give me a like. I'd appreciate that. Mwah. Cheers.